we could have something called a real image. If the image is real, we actually can have one of our letters, one of our friends that can tell us if the image is real. So please tell me, which of our friends is greater than or equal to or less than or absolute value of what? Tell us that the image is real. Laura.
Image distance.
What about it?
If it's greater than 0, then the image is and it's real.
It's real. Okay, so there are 3 things I want you to remember about the image being real, what it means to be a real image. Connie, give me something of what it means to be a real image. Actually, I think, Laura, you said one of them. What did you say?
If it's in front of the mirror.
So a real image is in front of the mirror. That's one of them. Connie, give me another one.
I'm not sure the
The reflected rays intersect. So far we have it's in front of the mirror, the reflected rays intersect, and the last one that makes it a real image. Because the reflected rays intersect, this is true. Stuart?
They can be focused on the screen.
It can be focused on a screen. That's what it means to be a real image. If the image distance is less than 0, this makes it what type of an image? Filippo?
Virtual image.
Virtual image. So, what does it mean to be a virtual image? Kevin?
For a virtual image, reflected rays do not intersect.
The reflected rays do not intersect. Give me another one, Stephanie. Because they do not intersect, the image cannot be focused on a screen. And the last one, Carol. Where is the virtual image? Behind the mirror. Good. That's real versus virtual. We can also have an enlarged image, or an image that's the same size, or a reduced image. Tell me how we know those. What letter will help us figure out those? Thank you. M stands for? Okay, so what about the magnification will make it either enlarged, reduced, or the same size? Say it again.
If it's enlarged, the absolute value of M is.
M, please say the word.
Magnification
Is?
greater than,
Good, keep going.
same size, the absolute value of magnification equals 1.
And?
And the magnitude or the magnitude of, the absolute value of magnitude would be less than 1.
I'm sorry, the absolute value of?
Magnitude. Magnification.
Magnification.
Would be less than 1.
I do understand that we often say magnitude instead of magnification, but M, capital M, stands for magnification. We have as well the concept of upright versus inverted. How do we know if something is upright versus inverted? Abigail.
If M is greater
And?
than magnification is greater than 0, it's going to be upright, and magnification is less than 0, it's going to be.
Great. We have 4 things that are true about convex mirrors. 3 of them have to do with the image characteristics, 1 does not. Please tell me things that are true, always true for convex mirrors. Tyler, give me something.
Virtual.
Keep going. Virtual.
Upright. Sorry.
Virtual, upright,
And reduced.
and reduced. These 3 things are always true of the image characteristics for a convex mirror. Again, I will give the asterisk with the always in that for real objects. If you have something that's not a non-real object, it's not true. There's one other thing that's always true for convex mirrors. It doesn't have to do with the image characteristics. What's the other thing that is always true? Abigail.
F is less than 0.
I'm sorry, Abigail. F.
Focal length.
The focal length
Less than 0.
is less than 0. Good. So those are things that are always true for convex mirrors. So just to take a look at it, just as a visual statement, if this is our mirror and our object is on the left-hand side of the mirror, which it usually is, this makes this, bless you, the real side of the mirror, and this the virtual side of the mirror. We have 3 rays that we draw for the ray diagram. Please just give me the names of all 3 rays. Yeah.
Parallel ray.
Keep going.
Chief ray.
Chief ray is the third one.
Oh, and.
That's fine. I'm just parallel ray.
Incident ray.
We'll talk about that in a minute. That's not. You'll understand in just a second, Donald.
Focal ray.
The focal ray. Now, each one of these three rays that we draw for our ray diagram are composed of both an incident ray and a reflected ray. What does it mean to be an incident ray? Incident ray. Ms. Martin?
It means that it's like the ray coming from, or going towards the mirror.
The incident ray is the ray that's going toward the mirror. The reflected ray is the one that's going away from the mirror. So each of the rays that we draw, parallel, focal, and chief ray, is actually composed of two rays, an incident and a reflected ray. The incident ray for the parallel ray goes what, Carolyn?
The incident.
How do we draw the incident ray for the parallel ray?
It is parallel to the,
Parallel to what? The line down the middle. Yes,
Yeah.
the line down the middle is called, Donahoe? The principal axis. So it goes in parallel to the principal axis. Daniela, the reflected ray for the parallel ray goes where? Through the focal point. Okay. The focal ray. Who can describe how the incident and reflected ray for the focal ray and compare it to the parallel ray? Because that's really an important piece, is to be able to compare this to the parallel ray. Carolyn.
it's parallel to the incident ray.
Not quite what I'm going for. What I'm looking for here is we've got the parallel ray. We know the incident ray is parallel to the reflected ray. It goes through the focal point. But I want to know how does the focal ray go? And I want to compare it to the parallel ray. Mahesh.
Like the opposite?
It's just the reverse. I'm going to take and switch them. So the incident ray goes through the focal point, and the reflected ray is parallel to the principal axis. So notice we just switch those two. And the chief ray. Where does the chief ray go? Stuart.
Through the radius of curvature.
Both of them go through the radius of curvature. Both through the radius of curvature. And the chief ray is the only ray that is undeflected. It actually does not turn at all. It just keeps, it goes both, the incident and the reflected ray are both on the same line for the chief ray.